Okay, welcome to the lecture for the homework that's after our first encounter with proofs, homework 9. And I'm going to work through some of these. It's really just about getting familiar with the rule sheet. Remember, always keep the rule sheet out when you work proofs, when you watch my videos and all the rest. Use that as a guide to work the problems and to also help you to reference what I'm talking about in those other materials. Okay, this thing really is the crucial thing for solving proofs. So for 619, the first one, I've set it up. Remember, open it up from the Fitch exercise files and make sure you show your step numbers, as I've already done here. And let's start building this. So the first thing you always try, this is one, is or elim. You can only try this if you have access, if the rule allows you to use it. How do you know if you can use it? This is where logic is in part about learning to follow directions, which means comprehending and understanding them. It says there must be an or sentence somewhere up above. That means the or is the main connective. And if you don't have that met, then you cannot apply or elim. So in 619 here, some of you, and this is a good mistake to make, a lot of people make it, but it's also indicative of whether or not you're following this strategy, this first strategy of applying or elim. If you look at 3 and you say, oh, the main connective there is or, it's A or C, so therefore I can apply or elim, that is actually fundamentally wrong, and that will get you off on the wrong track. When you try to apply or elim, you never ever look at the line that you're at. In this case, the line that you're at is indicated by the pointer, number 3. You only look above, and you have to have or as the main connective. So I have an or in 1 and also in 2 as the main connective. That means you're actually going to have to apply or elim twice off of each of those ors. So I choose here the rule or elim. Okay. Anytime you choose the rule, remember you always got to look it up in your rule sheet. So you scroll down to or elim, and then in the bolded area right here, I basically tell you how to set up or imitate what you see in the rule sheet itself. Okay, so the first thing you need is there are two subproofs. So I go up to this, I add a proof, I go add step before, because this is the conclusion, always stays in the bottom. I then go to proof, new subproof, add a few steps after, just to extend it out. And then this is the next most important step. You have to make sure you end the subproof. So I end it. It takes me out. And as soon as I end it, the next most important step, you have to then start a new subproof, giving you the separator, the separation between the subproofs. And then add a few steps after just to make it look like a subproof. Okay? So there's the first thing taken care of in the bold. First thing I need the two subproofs. The second thing you need is at the top of each of the subproofs, each of the subproofs, which is each of the cases of the or, write each of those cases. So at the top of the first subproof, I have to choose which or I'm using here. Am I using 1 or 2? Well, go for the easier one. 1 looks easier, it's more simple. So type in capital A as your first case, and then at 6, your second case, capital B. Okay? So far so good. Make sure you got that checked out first. Then the third thing is at the bottom of each subproof you need the same S. How to identify the S? Remember, the S is identified by wherever your or elim is at. So in this case it's number 9. That is my S. So I'm going to cut and paste that at the bottom of each subproof at 5 and at 8 in this case. You then go back down to 9, and the last thing you need to do to get this to check out, because if you check it now it will give you the X, is the highlights. So if you look at the rule sheet on the left, there's 3 things highlighted: the pure Q, the first subproof, and the second subproof. So in this case my pure Q is 1. That's what I chose as my or. Your or elim is stemming off of that. The or elim is, I'm going to test out each of these cases. So the first subproof is, let's explore the first case, which is A. And then the second subproof is, let's explore the other case, B. And you have to end up at the same common denominator, S. I check it, it's good now. Anytime you get the check, then and only then can you move up. Okay, in general, you can move up to either subproof, but the hint is you should try to look ahead. Look at the one that makes more sense to you, the one that looks like it has some relation. If you look at the second subproof from B to A or C, there's no connection there. It's B to A or C. There's no relation between these three things. But the first one says from A to A or C. So let's move up there. Anytime you move your pointer up, you go back to the first page and you cycle through these strategies all over again. So you first try or elim. Can you use it? And the answer is, in order to answer that, you have to first determine what the criteria for application is. First, you need an or as the main connective, and secondly, it has to be above the line you're at. So at this stage, 5, you never look at that line. You look above. So I have access, remember, to above and to the left. 4, 3, fall to the left. 2, 1. 1's already in play. That's out. And anytime you're using or for elim, you're not going to use it again. 2, however, is a new or. You haven't used that yet. So you might think, okay, great, I used that there. Remember, these guessing techniques work most of the time, but they're not guarantees. In this case, if you use or elim from 2, that's actually overkill. You don't need it. Think about it. Does not B or C have any relation to A or C? There's the C in common, but no relation to A. And in fact, if you think about it more carefully, in 3 you already have A, and from there you should be able to get A or C. You don't need or elim and all that extra tedious, difficult machinery. In this case, you know from or, the truth table for or is true when at least one of the sides is true. That means you need one of the sides above. So you have it right here in 3. And this is where you kind of have to get more familiar with the rules and not just rely on the rule sheet, but remember sort of your past experience with the truth tables and also our first passive proofs. There is a rule corresponding to the idea that if you have one of the sides of the or, you can then introduce the or. If you're uncertain, a good guessing technique is, well, there's an or here. Let's look at the or rules. Maybe they'll help me out. And indeed, there is one that fits that pattern. Not or elim, which has all this 2 subproofs and stuff. If you guess poorly, you're going to get just further confusion and answers that don't work for you. Rather, try to guess more intelligently. There's one that fits that pattern right here. If you have one of the sides of the or, then you can say that thing or anything, right? And that fits this pattern right here. I have my P, that's one of my sides, and then P or whatever. In this case, it's A and A or C. And that rule is called or intro. Check it, you're good. So it turns out you don't need step 4. That was just there when we set up the subproof, so let's delete that. Okay, so this first subproof is done. Now we got to do the other one. So move back down to 7. Anytime you move your pointer, again, you cycle through the strategies. That's the way this stuff works. That's the way this algorithm works. So first you try or elim again. Okay, in order to apply it, I need an or somewhere above as the main connective. What do I have access to at 7? 6, 5, remember there's a gap here, fall to the left, 2 and 1. Here is where the other or comes into play. There's an or there as the main connective. 1 is already in play, that's out, because you've used that here at 8. So this is the new or, so you're going to set up or elim here, because you can apply it. Remember, this is one of your most powerful guessing strategies, and you hope it works out. You don't know, but you're just trying it out. Okay, so there's an or there. Or elim is what I pick. So you go, anytime you choose a rule, you go back down to and look up the rule, and here it is, and it tells you that, again, we have the same 3 things. So first thing, I need 2 subproofs. So sheesh, here we go. Proof, new subproof. Oh, it's getting ugly, but if you discount what it looks like and how it looks confusing, if you think it's just a repetition of this relatively simple logic, then you don't have to focus on all the other mess, all the other noise, and just focus on what you're doing. That's part of where logic becomes a discipline of mind. So you add a couple steps after, you end the subproof. Anytime after you end it, you got to start a new subproof, and then you add a couple lines after that. Okay, and now we're good. Let me hide the goal strip. And now we've got the 2 subproofs set up, so that's the first thing. The second thing is, at the top of each subproof, write each of the cases of the or. Okay, so at 6, what are my cases of the or? Well, what or am I talking about? Where did this all get started from? It's from 2, remember, that we identified as the or from which we're going to do or elim at 12. So my first case is not B, not capital B, and the other case is C, capital C. Okay, and then the third thing you need, at the bottom of each subproof, write the same S. So you might say, what's your S? What's where the or elim is at? So you might look at 13. But that's actually a mistake. It's not coming from 13. It's coming from 12. And in this case, they just happen to be the same S. But they may not be in other proofs. So make sure you're careful about where the S is coming from. It's always from the relevant or elim that you're doing. In this case, it's 12, not 13. So you paste it in at 8 and 11. This is all just setting up the format. It will not give you the check. The last thing you remember you always need is the highlight. So there's the first thing highlighted is the P or Q, in this case not B or C. Then secondly, you need the whole first subproof, which is not B to your S. And then the last one is the second subproof, which is your second case, from C, in this case, to S. Highlight those things, you're good to go. And now, once you get the check, you got to move up and you have to solve each of the subproofs. Always look before you leap. Yeah, that's part of logic. Think before you act, etc., etc. It's a check of your mind, thinking about the process of thinking. So 6 to 8 has not B to A or C. There doesn't look like there's any direct connection there, so maybe we should leave that one on the side. Whereas the second one, C to A or C, looks like there's a relation. Let's do that one first. So anytime you move your pointer up, again, you cycle through the strategy. So go back to the first page. First, I try or elim. The question is, can I use it? So in order to use it, I need an OR up above. I'm at 11 right now, so I look at 10, 9, fall to the left. 5, fall to the left. 2 and 1. In 10 and 9, there's no OR there, fall to the left. In 5, there's no OR there, fall to the left. 2 and 1 have ORs, but both of these are already being used. Once you use them once, you're not going to use them again. So OR elim as a strategy is out. So then you're on to the second strategy. Now and only now do you use the second strategy, the backwards method, yeah? And the backwards method says, if you look at it, first you look at the step that you're at, identify the main connective, and then choose intro. So I have to look, now you look at where you're at. When you do OR elim, you never look at the line you're at, only above. But when you use the backwards method, you now look at the line that you're at. So I look at line 11. What's the main connective there? It's OR. And then I'm going to guess intro, because that's what the backwards method is about. It's another guessing technique. So you identify the main connective and you guess intro. And then step 2 says, relative to the rule you entered, look up this rule. Remember, everything after this page is the library for looking this stuff up. So let's look at OR intro. What does it say? It says you need one of the sides of the OR above. That's what you have to usually etch in, or if you're lucky, it's already given to you. So what are my sides of the OR? A and C. So at 10, I might put A there, or I might put C there. But if you look ahead, you've already got one of the sides at 9. Turns out you don't need to etch in anything else. It's already given to you. You highlight that, because that's what OR intro says right here in the rule sheet. It says you need to highlight one of the sides above, and you get that to check out. So step 10 is not needed. You can delete that. And that second subproof right there is done. That leaves us with the first one, which is probably going to be the harder one, because it doesn't look like not B has any relation to this. Okay, so I moved it up to 8 now, and anytime you move it up, you go back to the first page and you cycle through this whole procedure again. So first thing, you try OR elim. Can you use it? In order to use it, you need an OR above as the main connective. 7, 6, fall to the left. 5, fall to the left. 2, 1. The only ORs again are 1 and 2. They're already in place, so OR elim is out as a strategy. So then you're onto the backwards method. Now you look at where you're at, identify the main connective, and guess intro. Where am I at? I'm at 8. What's the main connective? OR. What am I going to guess? Intro. There's more than one way to do this proof. I'm taking you through the mechanical way to do this. Okay? In my audio lecture and picture files, there's a slicker way to do this, and you should try that. So I need, for OR intro, anytime you choose the rule, step 2 says, if you read it, step 2 says look it up. So I look up OR intro. It says I need one of the sides of the OR above. What are my sides? The A and the C. If you look around, it doesn't look like either one is there, so you can guess either one. We don't know. Let's guess A. If that doesn't work out, we might have to guess C. So let's go back. Guess A. I highlight that, one of the sides, OR intro, it checks out. Anytime you get the check, then you move up. Anytime you move up, you repeat the process. Without my scrolling up here, I'm actually going to go through it in words. I try OR elim. Is that an option? Well, in order to use it, I need an OR above as the main connective. 6, 5, fall to the left, 2, 1. These are the only ORs. They're already in play, so that's out. So then I'm on to the backwards method. Step 1 says, step 1 of the backwards method 1 says, identify the main connective. But look, at 7, there is no main connective. This is basically what's called simple. So the backwards method says, You repeat steps 1 and 2 until you have atomic sentences or simples. Yeah? Once you have a simple, you go to step 4, which says you work top down. So since this is simple, we bypass steps 1 and 2, and we basically are on to step 4. We're going top down to try and connect up all what we did. The backwards method again breaks it down. It's called the backwards method because it's basically breaking things down into component parts. From this whole thing, it's moving up. In this case, back. That's what backwards is. It's actually up to the component parts. And then once you got the component parts, you work top down to try and get that. Top down means whatever you have access to. That's what top is. And then down is however many steps it takes in between. Try to get to these component parts. In this case, just A. So I need to get A. Look above. What do I have access to? 6, 5, fall to the left, 2 and 1. 1 and 2 are already in play. You're not going to get any help there. So all you've got is 5 and 6, and they don't seem to have any relation to 7. Let me add a step before. So let's try and think this through because this seems puzzling. What do 5 and 6 give me? 5 says B, 6 says not B. That's you guys should have this idea down from last time, or at least some inkling of it. That's a contradiction because you can't have these two things being true at the same time. You can't have B being true and also its exact opposite, not B, being true at the same time. And there's a rule that corresponds to that. There are contradiction rules. A contradiction is a kind of connective, if you remember. There's a rule here that says if you have something and its opposite, remember, it doesn't have to be exactly in this order. You just have to have access to these two things. Then you've introduced, you've created a contradiction. And then that's exactly what I've done here. So this rule is contradiction intro. I check it, and I'm good. And now, there's this funny rule that we also encountered last time that says if you got access to a contradiction somewhere, I mean by itself, not the whole subproof, but the contradiction by itself, which is an impossible object, then that means anything goes. You can say whatever you want. The real explanation for this comes right here in the rule sheet. You can try to read it, and if it makes sense to you, great. If not, don't worry about it. Just think, this is this funny rule that says if you got something that breaks the laws of logic, you can say whatever you want. If you want a political version of this, any of you who have read George Orwell's 1984, I might have mentioned this before in a previous lecture, the notion of newspeak. The idea is if you can get the population to basically violate logic, if you can get them to believe that up is down and down is up, and there's this thing called the Ministry of Peace, and people believe, what do you think by that name? Oh, it must perpetuate peace and good relations. And in fact, it's the ministry responsible for creating war and havoc, yeah, for other countries and upon even the population. The idea here in 1984 is if you can get people to believe these contradictions and they suck it down, you can get them to believe anything. This is not just sort of fictional kind of stuff. I mean, in the recent election, one of the things that's people out now is you got people who were actively perpetuating false media stories on Facebook, and the public easily sucked it down. And even worse than that, when they ran a series of studies on kids, high school kids and below, looking at real news stories and fake ones, the kids found the fake versions to be more authoritative than the real ones. It's a kind of visual contradiction that they're sucking down, and they don't even realize it, in which case you can say whatever you want these days and people will buy it. There's no fact checking anymore. How do you know what's in your interest if you don't know any better, right? Just by what you read on the stories. There's got to be better ways to sort of filter through what's coherent, what's not, what makes sense, what doesn't. This is why logic, again, even if it seems totally inapplicable to your lives, is an ancient art. It's an ancient art, sort of training your mind to strengthen it up, to then build the skill set so you can become, eventually, hopefully, a better thinker, a clearer thinker, someone who's, in essence, what logic is giving you is excuse the language, it's a bullshit detector. How do you detect bullshit? Well, you got to strengthen your mind to sort of begin to gain access to these arts. So anyway, a contradiction, logically speaking, is no good. That's like people saying whatever they want. Trump or whoever else says one thing, then they say the opposite. People don't recognize the contradiction, so then you can say whatever you want. If people don't call you on it one way or the other, you can say what you want and get away with it. That's no good. So in this case, logically speaking, if you've got a contradiction, you get access to it, you can say anything you want. And what are we after? In this case, we're after A. That's called contradiction elim. Elim is better termed extraction, but there's a symmetry between intro and elim. I prefer extraction. What can you extract from a contradiction? Anything you want. Anything goes. And that basically completes our proof. That's it. If you get the green check at the bottom, you're good. Remember, turn these things in to the grade grinder to check them and make sure they're right before you turn them into me. There's the completed proof. If you can't quite see this clearly, I have the answer file in the pictures in La Lima. Okay, that's 619. Let's move on now to the next problem. Remember, open this up from your Fitch exercise folder, and the next problem is 624. I'm not going to do 25 and 28. 25, I have a video link in the lecture. 28, I take you through that in the audio file and the picture file. At that point, you should try to do it more on your own, right? Don't rely just on my video. I'm trying to wean you off little by little to get you guys to do it on your own, which is good exercise for yourselves. Okay, so as always, you cut and paste what's on the bottom. This is another algorithm. We're building upon our algorithms from before. That's why logic requires persistence. And then you show your step numbers, most importantly. Where is it? There it is. Let's make this a little larger. Okay, so 624 says, assuming this form, if you remember, it's not parentheses or, that's the neither nor form, neither A nor B, show from that it follows that not A and not B. From neither A nor B, show it follows not A and not B. 25 goes in the opposite direction. From not A and not B, show it follows that neither A nor B. And that basically proves the De Morgans. We haven't proved this before. We just said they're equivalent, and I gave you some examples. But the question is, well, you might say that they're equivalent, but how do you know in every single darn case that whenever you have neither this nor that, it is equivalent to, the same as, not this and not that? There are, if you think about it, a potential infinity of cases where that would be true. So how do you know? You can't check them all one by one. How do you know that they're all true, that they're all equivalent? That's what a proof essentially establishes. It's dealing with a kind of infinity, but we're using reason to get at it. The mind has this unique ability to grapple with infinities even if we don't fully understand how that works. Yeah, it's a unique feature of the human mind. So we're going in one direction in 24, going from neither A nor B to not A and not B. And then in 25, you go in the reverse direction. From not A and not B, that's your premise, to, it gets just reversed here, neither A nor B. That means they go both ways. That means they're equivalent. Okay, so how do we solve this? So as always, you go to the first page. You first try or elim. Can I use it here? You look never at the line you're at, only above. Do I have an or there? Ah, you guys are like, yes, I have an or right there. Remember, it's always main connective. That's why we spent so much time with truth tables and prior to that, hammering home the importance of the main connective because it indicates the structure of the thought or the sentence, right? So in this case, it's neither A nor B. When you say it out in language, it actually gives you the main connective. Neither, not. So the not is the main connective. It's outside parentheses. So you cannot use or elim here because there is no or above as the main connective. So then you're on to number 2, the backwards method. So then backwards method says, now you look at the line you're at, identify the main connective, and guess intro. I'm at 2. What's the main connective? Is it the not? No, the first not only goes to A. That means there's something left over. The thing that joins these two sides together is the and. So the and is your main connective. So then you guess intro and intro. And anytime you guess a rule, you look it up in the sheet. And intro, if you remember, is making the Reese's. You need the ingredients, the peanut butter and the chocolate, to make the Reese's. So what are my ingredients here? So I add 2 lines before because there's 2 ingredients. One ingredient is not A. The other ingredient is not B. Put them together and you have your composite. So what do I highlight? If you look at the rule sheet, it highlights each of the ingredients, each of the component parts. It's 2 and 3. Check it, you're good. Okay? Now I've reduced this problem down to solving 2 and 3. This is the backwards method. So you've broken it down to 2 and 3. So you go back, anytime you get the check, you go back the first page, and then you just reset. You start all over again. You try to keep in mind what you did previously, but you also sort of reset and you sort of start afresh, right? You try or elim. It's basically a process. You guys, if any of you know anything about this, if in sports or whatnot, the process that you stick to, like sports is the best example, but there's a whole series of things where you can do this, right? You go through your process to repeat. Say if you're shooting a free throw. Under pressure, if you learn the process enough, it becomes a habit, and you can block out the things that don't matter and focus on the things that do. Likewise here, you block out the excess noise and you try to focus on the reasoning process. So I try or elim first. So I got to do 2 or 3. Which one do you want? Let's just move up to 2. We got to do both of them anyway. Let's do 2 first. Can I use or elim? Well, look above. All you got is 1. Is there an or there as the main connective? No. So that's out. So then you're onto the backwards method. Yeah? It says look at the line that you're at. 2. Identify the main connective. Not. Guess intro. So not. Go to intro. Not. And then anytime you guess the rule, scroll down to the rule itself, and here are the not rules. Not intro right there. The bold gives you what you need to do to set it up. Remember, anytime there's bold, that means you got a subproof. So the first thing you need is one subproof. So I add a step before, new subproof, right there. Add a couple of steps after just to extend it down. Okay. Second thing, at the top, write the opposite of the not sentence below. So this is my not sentence that I'm trying to, where the not intro occurs. It's not A, so I want the opposite of that, which is A. And then the last thing you need, 3, a contradiction at the bottom of the subproof. So 3 at 4, I put a contradiction. That's the third step of setting up not intro. The last thing you need to get this to check out is the boxing or the highlights. If you notice here, the whole subproof is highlighted. So in this case, I go down to 5, and I just highlight up here. It'll highlight the whole subproof. And there it is, your first not intro checked out. I move up then to 4. Anytime you move up, you start all over again. So first thing you try is or elim. Can you use that? Look above. 3, 2, fall to the left. No or. This is not, right? So then or elim is out. So then the backwards method. Look at the line you're at. 4, identify the main connective. Remember, the contradiction is a kind of connective. Guess intro. So I go intro, contradiction. You then look it up. I'm not going to do that here. You guys can do that on the side as you follow along in the video, and you do this in your at home. Not contradiction intro says you need something and its opposite. Yeah, you need basically, well, okay, fine, I'll scroll down. You need something of the form P and not P. So the hint here is basically you look for the not sentence above. Where is it? The only not sentence you've got is in 1. So what you're going to do is you're going to guess. This is a guessing technique. Guess the opposite of that. So at 3, I'm going to guess A or B, because that's the direct opposite of 1. Basically means you just drop the not and write that down there. These two things cannot be true together. So I highlight that and that, my not P and my P. Check it and it's good. Now I move up. Anytime you move up, repeat the process. So I go or elim. Is that an option? Look above. No or. You do that because sometimes when you write subproofs, the or actually pops up. Okay? In this case, no. So or elim is out. So now you're onto the backwards method. You look at the line you're at. The main connective is or. You guess intro. And then what do you need? You need one of the sides of the or. And what do you know? There it is in 2. If you have A, then A or B is true. But that's a contradiction from 1. That must mean my assumption A is no good. So not intro says not A. And if you follow that, the next one is almost the same. And I'm going to leave you guys to do this. I'm going to fill it in with the relevant portions, but try to fill out the reasoning. I have the full answer posted in La Lima in case you get stuck. You should try to fill in these rules on your own using that whole technique. So you go here, what do I use first? Can I use or elim? No, so you're onto the backwards method, and then you try to fill in these rules, working your way up like that. It's good practice. I'm going to go top down, which is fancier, slightly fancier. I got B, from which it follows that the side, or B because I have one of the sides, but in 1 it says I can't have that, so that's a contradiction. That must mean my assumption B is no good, in which case not B. Putting them together, I get not A, not B, which is 10. That's the end of the proof. So when you check it, that's what you're going to get. Turn the X's into checks. See if you can do that. Okay, that concludes the lecture, the video lecture for this homework. Remember, for 6.25, I have a video there also helping you out, and 6.28, I have the audio lecture and the picture files. This is where I'm trying to take off the training wheel somewhat and let you guys try to start to figure this stuff out a bit more on your own. That's good practice for you. Starting next lecture, we're going to start making the dry run to the midterm. So make sure you especially do those last 3 homeworks for the midterm. They are the ones that are getting you ready for the midterm. And there's hints contained therein, as well as especially in the review section for the midterm. So make sure you check those out. Okay, folks, keep at it.